Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So this is a new topic called inverse trigonometric functions. So one of the important topics where we generally lack the idea of concepts. So if we are clear in concepts in this particular chapter, then we can make sure that we can solve any kind of model question given in our exams. Okay. So in this upcoming series of videos, let us discuss more about inverse trigonometric functions and how the formulae are derived. First, let us see the definitions. Okay, and then we will see each and every formula of the inverse trigonometric function and their derivations, and then we will see many problems being solved in upcoming videos. So this is an introduction class to inverse trigonometric functions. First of all, we have to understand one thing. For a function to have its inverse, okay, for a function f of x to have its inverse called f inverse of x, function f of x must be bijective. So what is a bijective function? In functions chapter you might have learned it. What is a bijective function? A function which is both one function and also onto function. Okay, so if a function is both one and also onto, then a function is said to be bijection. Certainly we will see another video to define a bijective function very soon. So in this way, if a function is a bijective function, then we say that the function has an inverse. Then we say the function has an inverse. Okay, na? So in that case, trigonometric functions are not bijective functions in their natural domains. In their natural domains, trigonometric functions are not bijective functions. Why they are not bijective means they are not one in their natural domains. We will discuss why exactly. Okay, now then how come we can find inverse trigonometric functions means? So we can restrict their domains. By restricting their domains, we will convert trigonometric functions as one functions, and thereby they become bijective. And since they are bijective now, we can find their inverse. Okay, na? So once again I am repeating, trigonometric functions are not bijective functions in their natural domains, but we can restrict their domains to make them bijective. And once they are bijective functions, we can define their inverse functions. So this is what we are going to do in this introduction classes. So we will restrict the domains of trigonometric functions, and then in the restricted domain, we will start defining the inverse trigonometric functions. This introduction class about inverse trigonometry is very important. You got it? Do not miss it. Watch the video until the end. Fine? Let us start. To understand why exactly trigonometric functions are not bijective functions, let me draw the graph of a trigonometric function. Once again, let us draw the graphs of trigonometric functions to understand why they are not bijections. I am drawing a graph of the function sin x. So I will take the x-axis, so which contains the inputs for a trigonometric function sin x, and I will take y-axis. So we know what is the domain of the function sin x. If input is x, then the output is y is equal to sin x. So the domain of the function sin x is from minus infinity to plus infinity, which means that in place of x we can substitute any real number. Okay, so I will take the inputs in terms of angles 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on up to infinity, and then minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on up to minus infinity. So the domain of sin x is from minus infinity to plus infinity. So that is nothing but any real number. When it comes to range of sin x, the maximum value of sin x is going to be plus 1 and the minimum value of sin x is minus 1. Now if you draw the graph of sin x, so it's important that you should have proper basics in trigonometry. So to understand the chapter of inverse trigonometry anyhow. So if you know how to draw the graph of sin x, when the input is 0, the output is sin 0. Sin 0 is 0. Next, when input is 45 degrees, pi by 4, sin pi by 4 is 1 by root 2. 1 by root 2 is root 2 by 2. That is nothing but 1.5 0.414 by 2, which is 0.707. See, I am not teaching you how to draw the graph of sin x. You are supposed to have that knowledge already. Then when input is pi by 2, sin pi by 2 is going to be 1. So let me draw the graph. Similarly, we can complete the remaining part of the graph. You can learn this from the chapter of trigonometry, how to draw the graph of sin x. Okay. So we will discuss in detail if needed. And when input is minus 3 pi by 2, sorry, plus 3 pi by 2, the output is minus 1. When input is 2 pi, sin 2 pi is 0, and so on. Similarly, when input is minus pi by 2, the output is minus 1. And when input is minus pi, the output is 0. And when input is minus 3 pi by 2, the output is plus 1. And when input is minus 2 pi, the output is 0, and so on. The graph is smooth, please understand this. So dear students, when it comes to deciding whether a function is 1-1 or not, 1-1 function or not, after drawing the graph of a function, just draw a horizontal line anywhere in the graph. Draw a horizontal line. If the horizontal line intersects the graph of a function at more than one point, if the horizontal line intersects the graph of any function at more than one point, then it is not 1-1. If you look at this, here I am drawing a horizontal line. See, this horizontal line is intersecting the graph of sin x at more than one point. Here, 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 and so on. If I keep on intersecting, we will get infinite points of intersections. Not only here, you can draw anywhere. You got it? The horizontal line is intersecting the graph of sin x at more than one point, and therefore it is not 1-1. You got it? So in some other video we will discuss more about 1-1 functions and onto functions when we discuss the chapter of functions. Okay, come back to this. Now y is equal to sin x is not 1-1 function. Since it is not 1-1 function, it doesn't have any inverse in the natural domains. But what if I restrict the domain? Restrict the domain means I will not take the inputs from minus infinity to plus infinity. I will restrict the domain between two inputs. How do I restrict the domain? Please observe here. Three conditions are to be satisfied to take the restricted domain. Okay, na? To make a function 1-1 here. What are the three conditions that I am going to choose? Please observe here carefully. What are the three conditions that we will keep in mind while choosing the restricted domain? Please observe this. The first condition is that the graph is continuous. The graph of f of x is continuous in the restricted domain. Okay, now keep this in mind. Second thing is the range remains same. Okay, the range in the natural domain and the range in the restricted domain both must be same. And what is the third thing? The numerical values in the restricted domain, RD means restricted domain. Okay, the numerical values in restricted domain are smallest possible values. Why means we can create so many restricted domains. There are so many restricted domains, but I will choose that particular domain where the values are smallest, where the numerical values are smallest, and preferably positive. Preferably positive means if you have a choice of choosing a negative one and positive one, I will prefer the positive one. Let us understand this in detail while restricting the domain of sin x. Please observe this. Of course, the graph of sin x is continuous everywhere. Okay, fine. Next, the range remains same means the range of sin x in its natural domain is minus 1 to plus 1. Minus 1 to plus 1. So, in the restricted domain also, the range must be minus 1 to plus 1. So, look at this carefully. I can choose the inputs between minus pi by 2 and pi by 2. I can choose the inputs between minus pi by 2 and pi by 2. If I choose the inputs between minus pi by 2 and pi by 2, sine of minus pi by 2 is minus 1. You got it? Sine of plus pi by 2 is plus 1. And the graph is taken like this. Look at this. See, between minus pi by 2 and plus pi by 2, the graph of sin x is continuous and the range is from minus 1 to plus 1. We are getting all the outputs from minus 1 to plus 1. And next, Okay, now these two conditions are satisfied, and some of them can say, sir, why can't I choose the restricted domain between pi by 2 and 3 pi by 2? Why the other student is saying that he will take between pi by 2 and 3 pi by 2 means in between this particular two values also the value of sin x is changing from +1 to -1. Here also the range is -1 to +1 only. Another student will say, sir, I will take the restricted domain between -3 pi by 2 and minus pi by 2. Why -3 pi by 2 and minus pi by 2 means here also the value of sin x is changing from -1 to +1. Okay, now like this we have infinite possible restricted domains, but I will choose only one among them. What is that? Let us see here. What is it? My first choice was between minus pi by 2 and plus pi by 2. Next, the second choice was from pi by 2 to 3 pi by 2. And the other choice was minus 3 pi by 2 to minus pi by 2. So like this we have so many infinite possibilities. Okay, my first choice was minus pi by 2 to pi by 2, then it was pi by 2 to 3 pi by 2, and then minus 3 pi by 2 comma minus pi by 2, and so on. Out of this, which one is eligible to become the restricted domain? Now it is decided by the third condition. What is it? The numerical values in the restricted domain are smallest possible values for f of x is equal to k. For example, let me take sin x is equal to 1 by 2. Sin x is equal to 1 by 2. If sin x is equal to 1 by 2, x the input, okay now, if you want to take the value of x in this particular domain, then x is equal to 30 degrees, right? Sin 30 degrees is 1 by 2. 30 degrees means what? Pi by 6. If I want to take x value from this restricted domain, then x is equal to, so between 90 degrees and 270 degrees, when do we get 1 by 2 means, of course, for 150 degrees, correct or not? Sin 150 degrees is also 1 by 2. 150 degrees means 5 pi by 6. And next, again, if you want to take x value from this domain, then x is equal to, the x value is going to be minus 210 degrees. Minus 210 degrees means minus 7 pi by 6. Now, dear students, see here, which restricted domain am I going to choose? The one which gives me numerically smallest value and preferably positive. So, it's very clear that pi by 6 is numerically smallest out of this. Pi by 6 is numerically smallest out of this, and it comes from minus pi by 2 to plus pi by 2. Therefore, the restricted domain is going to be minus pi by 2 to plus pi by 2. So, dear students, if I restrict the domain between minus pi by 2 and plus pi by 2, let me erase the remaining part. Let me erase the remaining part. I have erased the remaining part, right? So x and y is equal to sin x. Now for the function, you got it, the domain is going to be minus pi by 2 to plus pi by 2, the restricted domain. In this restricted domain, this is the graph of y is equal to sin x. This is the graph of y is equal to sin x, and if I draw a horizontal line, it is intersecting the graph at only one point, maximum one point. Wherever you draw, it intersects the graph at 1 point or 0 points. Are you understanding this? So, if the horizontal line is intersecting the graph at maximum 1 point means that particular function is going to be 1 function. So now in the restricted domain of minus pi by 2 to plus pi by 2, y is equal to sin x is a 1 function, and already it is onto function because the domain codomain is equal to range. Okay, now codomain is equal to range. We will learn more about onto functions in the chapter of functions 1 and onto. Okay, now so dear students, now after restricting the domain, sin x function is a 1 function and already it is onto function. Therefore, y is equal to sin x is bijection. Is a bijective function. It is a bijective function. since it is a bijective function, its inverse exists. Yes, now sin x is bijective. Similarly, if you apply the same concept, okay na, for cos x graph, tan x graph, cosecant x graph, secant x graph and cot x graph, we can restrict the domains to make sure that those trigonometric functions are also bijective functions. You got it? Let me quickly explain how to restrict the domain for remaining trigonometric functions, and then we will write a table of restricted domains. Here is the graph of y is equal to cos x, just like we have described for y is equal to sin x. So in its natural domain, y is equal to cos x is not bijective function. Why it is not bijective function means, if I draw a horizontal line, it intersects the graph at more than one point, therefore it is not one function, and hence it is not bijection also, and therefore we are going to restrict their domains. And what are the different possible restricted domains means, between 0 and pi, the graph of cos x will change from +1 to -1. The range remains same. The range remains same, -1 to +1. And even in the domain between pi and 2 pi, even between the domains pi and 2 pi also, the graph of cos x changes from -1 to +1. Even in the domain between minus pi and -2, 0 and minus pi also, the graph of cos x changes from +1 to -1. So we have different options for restricted domains. But why are we choosing 0 to pi as restricted domain? I have told you, for cos x is equal to 1 by 2. For example, for cos x is equal to 1 by 2, in this particular domain, x value will be 60 degrees. That is pi by 3. And in this particular domain, x value is going to be 5 pi by 3. Cos 5 pi by 3 is also 1 by 2. And in this particular domain, x value is minus pi by 3. X value is minus pi by 3. Cos of minus pi by 3 is equal to 1 by 2. So we have different possible restricted domains. But why are we choosing 0 to pi? Because the numerical value in this particular restricted domain, the numerical value that we have got, pi by 3, is the smallest among pi by 3, 5 pi by 3, minus pi by 3 and so on. Of course, you can say, sir, in here and here numerical value is pi by 3 only na, then why are you choosing 0 to pi instead of minus pi comma 0? You might ask me. I also told you in brackets, what is it? Preferably positive. Preferably positive. Here numerical value is pi by 3, here also numerical value is pi by 3, but why I am choosing plus pi by 3 instead of minus pi by 3 means, our choice will be preferably positive. So therefore the restricted domain of cos x will be 0 to pi. The restricted domain of cos x will be 0 to pi. Next, tan x. Okay, here is the graph of y is equal to tan x. The domain, the natural domain of tan x is going to be any real number except odd multiples of pi by 2. That is the natural domain. And the range of tan x, is from minus infinity to plus infinity. Okay na? So in its natural domain, tan x is not a bijection because it is not 1 1. Why it is not 1 1 means, if I draw a horizontal line, it is intersecting the graph at more than 1 point. Therefore it is not a 1 1 function, and therefore it is not a bijection in its natural domain. So I am going to restrict the domain. Instead of taking the domain from minus infinity to plus infinity, I am going to restrict the domain. How I am going to restrict the domain means, the first condition is that the graph must be continuous. The second condition is that the range remains same. Range remains same means, after restricting the domain also, the range must be minus infinity to plus infinity. And the third condition is that numerical values in the restricted domain are smallest possible values, So I have got you some domains. I have got you some restricted domains where the range of the graph y is equal to tan x is from minus infinity to plus infinity. I have got you some. So what are they? Between minus pi by 2 and plus pi by 2. Look at this region between minus pi by 2 and plus pi by 2. This region. this region. The graph of tan x changes from minus infinity to plus infinity. That means the output changes from minus infinity to plus infinity for the inputs between minus pi by 2 and plus pi by 2. Similarly, the output of y is equal to tan x. The output changes from minus infinity to plus infinity even for the inputs between pi by 2 and 3 pi by 2. And also for the inputs between minus 3 pi by 2 and minus pi by 2, the output of tan x changes from minus infinity to plus infinity. I have given you some restricted domains in which we are going to choose only one. Which one? The one which gives us numerically smallest values. Okay, I have taken an example. Tan x is equal to 1. Tan x is equal to 1 means x can be pi by 4. That pi by 4 is chosen from first domain, and then x can be 5 pi by 4 because tan of 5 pi by 4 is also 1 only. Okay na? And 5 pi by 4 is chosen from this domain. Next, tan x is equal to 1 even for x is equal to minus 3 pi by 4, and minus 3 pi by 4 is chosen from this domain. Out of these three values, the numerically smallest is pi by 4, and therefore, dear students, we are choosing the first one between minus pi by 2 comma plus pi by 2 as restricted domain. And when we are restricting the domain, let us see how the graph changes. You can try it for y is equal to cos x, because I didn't explain this particular thing for y is equal to cos x. Okay, now when I am restricting the domain only between minus pi by 2 and plus pi by 2, look at the graph of y is equal to sin x, y is equal to tan x. Here is the graph of y is equal to tan x. In its restricted domain between minus pi by 2 comma plus pi by 2. So in its restricted domain, the tan x graph is continuous. You can draw it continuously. Second thing, the range remains same. The range is from minus infinity to plus infinity. Minus infinity to plus infinity. The range remains same. And third thing is, we have got the numerically smallest values. Therefore, what is the restricted domain for y is equal to tan x? The restricted domain is minus pi by 2 comma pi by 2. The restricted domain is minus pi by 2 comma pi by 2. So in this way, we will choose the restricted domains for trigonometric functions to make sure that they are bijective functions. So now let me tabularize the domains, restricted domains, and also range of the trigonometric functions. And as an assignment and as a work from your side, you draw the graphs of cosecant x, secant x, cot x, and you decide the restricted domains by satisfying these three conditions, such that the restricted domain satisfies these three conditions. Okay na? This must be done by you, and if you are successful in that part, then I'll tell you one thing, you are going to be successful in this particular chapter very easily. There is no doubt in that. See, I have explained you how to get the restricted domains of sin x, cos x and tan x by drawing their graphs. You draw the graphs of cosecant x, secant x and cot x, and you find out the restricted domains such that these three conditions are satisfied, and cross check whether the restricted domain that I have written on the board matches with your restricted domain or not. Here are our 6 trigonometric functions, and let us revise their natural domains and their range. Then I'll write restricted domains. Okay, the natural domain of sin x is any real number, so x can accept any value from minus infinity to plus infinity, and for cos x also the range is, the domain is R. For sin x and cos x, the natural domain is any real number. Okay, next, see, I'll tell you one thing. If you remember trigonometric identities, okay na, it's very easy to remember the natural domains. We know that sin square x plus cos square x is equal to 1. Therefore, these two will have same domains. We know that secant square x minus tan square x is equal to 1. Secant square x minus tan square x is equal to 1. And therefore, these two will have same natural domains. What is it? Any real numbers except odd multiples of pi by 2. Even for secant x also any real number except odd multiples of pi by 2. And then cosecant square x minus cot square x is equal to 1. Cosecant square x minus cot square x is equal to 1. Therefore, these two will have same domains. What is it? Any real number except multiples of pi. Any real numbers except multiples of pi. The original reason why tan x and secant x will not accept odd multiples of pi by 2 is what? Because tan x and secant x have cos x in their denominators. Cos x in their denominators. Tan x is sin x by cos x. Secant x is 1 by cos x. And cos x cannot be equal to 0. Therefore, x cannot be odd multiples of pi by 2. That is the original reason. But you can remember like this. Using the identities, we can write their natural domains. And similarly, the range of sin x and cos x is minus 1 to plus 1. The range of tan x and cot x is same. The range of tan x is any real number. The range of cot x is any real number. And since sin x is between minus 1 and plus 1, its reciprocal cosecant x is not between minus 1 and plus 1. That means the range of cosecant x is minus infinity comma minus 1 union 1 to infinity. Same way, since cos x is between minus 1 and plus 1, its reciprocal secant x is not between minus 1 and plus 1. So minus infinity comma minus 1 union 1 comma infinity. I have written natural domains and range that you might have learnt already in trigonometry chapter. You should. Okay na? So restricted domains. When it comes to restricted domains, as I have derived already, the restricted domain of sin x. See, in natural domains, these functions are not bijections. But in restricted domains, these functions are bijections. So the restricted domain for sin x is going to be minus pi by 2 comma pi by 2. For cos x it is 0 to pi. For tan x it is open bracket minus pi by 2 comma pi by 2. You got it? These three we have derived it already. And I told you to find out the restricted domains for remaining three. If you use their graphs and if you follow the steps that I have detailed, so the natural domain of cot x looks like cos x. What is it? Here closed bracket 0 comma pi and here open bracket 0 comma pi. The natural domain of, the restricted domain of cot x looks like cos x. Okay na? Secant x, cosecant x, it is easy. Because their their restricted domains looks like their reciprocals. Okay na? Secant x reciprocal is sin x. Its restricted domain is minus pi by 2 comma plus pi by 2. So therefore, not secant x. Secant x reciprocal is cos x. Secant x reciprocal is cos x. Its restricted domain is 0 comma pi. Therefore, what is the restricted domain of secant x? It is also 0 comma pi only, except the middlemost value pi by 2. Except the middlemost value pi by 2. You got it? You will understand why if you go with the graphs. Next, when it comes to a restricted domain of cosecant x, it looks like its reciprocals. It looks like minus pi by 2 comma pi by 2 only, minus pi by 2 comma pi by 2, except the middlemost value is 0. You got it? So I want every student who is watching this video to find out the restricted domains of these three and comment in the comment section whether you have got the restricted domains or not. In case if the students are unable to find out the restricted domains, then certainly I will find a time to upload a video where I will explain how to find the restricted domains of these three if needed. But I hope that almost all of you will get it. In case if you are unable to find out the restricted domains, then I will upload another video where I will explain how to find that restricted domains of these three. Okay na? So therefore this table is very important. Okay, restricted domains of these. So after this, let us ignore natural domains. After this, let us ignore natural domains. Let us ignore natural domains. Okay na? Now trigonometric functions are going to be bijections only in this domain and for this range. Okay, trigonometric functions are going to be bijections when this is the domain and this is the range. So sin x is bijection if this is the domain and this is the range. Cos x is bijection if this is the domain and this is range. Similarly for the remaining also. Okay na? Let restricted domain is represented by capital A and the range is represented by capital B. Let restricted domain is represented by capital A and the range is represented by capital B. So now I am going to define inverse trigonometric functions. Okay, now listen carefully. So remember what is capital A and what is capital B for all. Okay, now our first definition, let f is from A to B. Let f is from A to B, where A is the domain and B is the codomain. Okay, na? So where the domain is minus pi by 2 comma pi by 2 and B is the codomain minus 1 comma 1 plus 1 and defined by f of x is equal to sin x. So in this domain and in this codomain, sin x is both 1 1 and also on 2. Sin x is bijection. F of x is equal to sin x is bijection. And now I can define its inverse function as f inverse, whose domain is B and codomain is A. F inverse, whose domain is B and codomain is A. What is B here? Minus 1 comma plus 1. And what is A here? Minus pi by 2 comma plus pi by 2. B is minus 1 comma plus 1 and A is minus pi by 2 comma pi by 2, defined by f inverse of x is equal to sin inverse of x. So sin inverse of x is the inverse function of sin x with domain minus 1 comma plus 1, between minus 1 comma plus 1 and codomain as this. So this is the first inverse trigonometric function, sin inverse of x. Similarly, we can define the inverse trigonometric functions, cos inverse of x, tan inverse of x, etc. So what is it? A small changes here. If A is from 0 comma pi and B is from minus 1 comma plus 1, then the function f of x defined by cos x. That means in this domain and in this codomain, cos x is also a bijective function. Then what is its inverse function, f inverse? Where B is from minus 1 comma plus 1 but A is from 0 comma pi. Defined by f inverse of x is equal to cos inverse of x. Okay, now so that is the inverse function of cos x. The inverse function of cos x is cos inverse of x with domain minus 1 comma plus 1 and codomain 0 comma pi. Similarly, for tan x, what is the domain of restricted domain of tan x? It is between minus 1 comma minus pi by 2 comma plus pi by 2, and the codomain is any real number. The codomain is any real number. Defined by f of x is equal to tan x. So in this domain and in this codomain, tan x is bijection. Therefore, its inverse exists, and f inverse is from B to A. So what is B? B is any real number, and what is A? A is between minus pi by 2 comma pi by 2. And what is the inverse function of tan x? Inverse function of tan x is tan inverse x. So therefore, for the function tan inverse x, the domain will be any real number and the codomain will be minus pi by 2 comma plus pi by 2. Same way, next, if you talk about cortex, its domain will be between 0 to pi and its codomain will be any real number. Then cortex will be bijection. Then its inverse exists. Its inverse is from B to A and B is any real number. A is 0 to pi and its inverse is given by cot inverse x. Its inverse is given by cot inverse x. Cot inverse x is a function with domain as any real number and codomain as 0 to pi. Similarly, if you take secant x is a bijection if its domain looks like its reciprocal cos x. Looks like its reciprocal cos x means from 0 comma pi except pi by 2. And its codomain is from minus infinity comma minus 1 union 1 comma infinity. So for this particular domain and codomain, secant x is bijection. And secant x is bijection means its inverse exists. Its codomain will be, the domain of the inverse function will be minus infinity comma minus 1 union 1 comma infinity. And the codomain will be 0 comma pi except pi by 2. In that case, the inverse of secant x is given by secant inverse x. So therefore, secant inverse x is the inverse function of secant x. If the domain is minus infinity comma minus 1 union 1 comma infinity, and its codomain is 0 comma pi except pi by 2. And the last one is the cosecant x function with the domain which looks like its reciprocal's domain, the restricted domain of course, its reciprocal's domain between minus pi by 2 comma plus pi by 2 except 0, and codomain is this only. So in this particular domain and codomain, cosecant x is a bijection, therefore its inverse exists. And what is it? Here a is minus pi by 2 comma pi by 2 except 0. So therefore the inverse of cosecant x is given by cosecant inverse x, whose domain will be this and codomain is this. So these are the 6 inverse trigonometric functions with their respective domains and codomains. Let me list out once again in tabular form. Here is the tabular column. For sin inverse x, in place of x, what values can I substitute? Any value between minus 1 comma plus 1, and of course minus 1 and also plus 1. Okay, na? Any values from minus 1 to plus 1. So the domain is from minus 1 to plus 1 for sin inverse x, and its range is from minus pi by 2 comma plus pi. For cos inverse x also, its domain is from minus 1 to plus 1. That means in place of x, I can substitute any value from minus 1 to plus 1. And its range is 0 comma pi. Next, for tan inverse x, its domain is this, minus infinity to plus infinity, and its range is between minus pi by 2 comma plus pi by 2. And for cot inverse x, the domain is minus infinity comma plus infinity, the range is between 0 comma pi. And for secant inverse x, this is the domain, and the range of secant inverse x looks like that of cosecant inverse x. What is it? 0 to pi, except the middlemost one, pi by 2. And for cosecant inverse x, its range looks like that of sin inverse x, which is minus pi by 2 comma pi by 2 except 0. It's very important for us first to understand how to find the domain and range of inverse trigonometric functions, and after understanding, now let us by heart them, because while solving the problems, this should come immediately to our mind. What is the domain of sin inverse x? What is the range of sin inverse x? It should come to our mind immediately. Only then we can solve the problems as quickly as possible. So dear students, after understanding how to find the domain and codomain, the domain and range of sin inverse x functions, you got it? So then you start by hearting these values. You start by hearting them. Remember them. You got it? What is the domain of each inverse trigonometric function? What is the range of each inverse trigonometric function? You start remembering it. You got it? So it's very important to remember, as I have told you. Now a little different approach to tell why sin x, cos x, tan x, etc. are not bijections and doesn't have inverse in their natural domains. A little different approach, a basic approach, you will understand this easily. So we know that sin 30 degrees is equal to 1 by 2, and sin 150 degrees is also 1 by 2. You got it? You got it? Because I am taking the domain as minus infinity to plus infinity. So this is a function. Yes, sin x is a function, of course. You got it? If I try to define its inverse in its natural domain, let us see what happens. What is sin inverse of 1 by 2? If sin of something is 1 by 2, then what is sin inverse of 1 by 2? You got it? If sin of something is 1 by 2, if sin of some input is 1 by 2, then to get the output called 1 by 2, what input is being taken? Okay, now or simply sin inverse of 1 by 2. Okay, now according to this, students will be writing, sir, 30 degrees is correct, 150 degrees is correct, and so on. That means for one particular input you are getting multiple outputs. For one particular input you are getting multiple outputs. And in functions, it is not accepted One input for a function cannot give you multiple outputs. If there is any function, actually I should not call it as a function, if there is something which gives me multiple outputs for the same input, then it is not a function at all. That means sin inverse of x is not a function. Sin inverse of x is not a function in its natural domain. That's why we said inverse does not exist, because for one input we are getting multiple outputs, and for functions one input should not give you multiple outputs. That is the reason why the sin inverse of x does not exist if this x belongs to the natural domain, and that is the reason why we have restricted the domain between minus pi by 2 comma plus pi by 2. So between minus pi by 2 comma plus pi by 2, the only possible answer is 30 degrees. 30 degrees means pi by 6. Now one input gives me one output. Now it is a function. So I hope you understood this another method of understanding why trigonometric functions are not bijections and their inverse does not exist in their natural domains. Okay now. So thank you dear students. This is an introduction class of inverse trigonometry. So in our next classes, let us understand how to draw the graphs of inverse trigonometric functions. Very important. Some of you might be skipping how to draw the graphs of trigonometric functions or inverse trigonometric functions. But let me tell you one thing. While learning something in your IITs, what's more important, understanding concepts completely or solving hundreds of questions? What do you think will make you successful? It's understanding the concepts completely. Are you understanding this? The one who understood the concepts completely will certainly crack the problems like anything. So instead of running behind solving the problems, solving hundreds of problems, my advice is to work more on the concepts. Understand the concepts completely and see the wonders while you are going to solve the problems. Thank you. This is M. Sandeep Kumar. I hope you understood this concept, and if you have understood this, do like the video, subscribe my channel if you have not yet subscribed, and comment what you felt about, and please find out the restricted domains of cosecant x, secant x and cot x using their graphs, using the methodology that I have used, and let me know whether you have found those restricted domains or not in the comment sections. You got it? So if in case if many students are commenting that they are unable to get the restricted domains, then certainly I'll make a video on that also. And thank you. That's it for today's video. In the next video we'll continue with the graphs of inverse trigonometric functions. Take care.